So, you've heard the word blockchain, right? Probably right next to Bitcoin. But here's the thing. What if I told you it's not really about digital money? It's about solving a huge problem the internet was never, ever built to handle. And that problem is trust.
So that kind of begs the question, right? We've got the internet. It connects billions of us in like an instant. Why on earth do we need this other super complex sounding thing called blockchain? What is the problem it's even trying to solve?
Well, to really get it, we actually have to take a step back and look at the internet itself. We need to understand this one crucial piece that it was just never designed to handle.
And yeah, here it is. For all its amazing power to share information, the internet is, at its core, a giant copy machine. It never had a built-in way for us to trust each other when something valuable, like money or a legal document, is being exchanged.
Think about it like this. In the real world, a handshake can seal a deal. It's direct, person to person. But online, nothing is direct. To send money, to sign a contract, we always need a middleman, a bank, a credit card company, a lawyer, someone to stand in the middle and verify everything.
And you know what? This whole system of middlemen, it's slow, it's expensive, and honestly, it's surprisingly fragile. That international payment you're making, it could take days to clear. Every single company involved has to keep its own separate, often conflicting records, and these central hubs, they are just giant, juicy targets for hackers. And maybe worst of all, billions of people around the world can't even get access to this system in the first place.
So that got some people thinking. What if you could build a system for value that worked more like the internet itself, without a central authority? Back in 2008, a mysterious person, or maybe a group, set out to do exactly that. They wanted to create digital cash that just didn't need a bank.
This quote right here is from the abstract of the original Bitcoin paper, written by the anonymous Satoshi Nakamoto. And the vision was, well, it was simple but totally radical. True peer-to-peer electronic cash. But to pull this off, they had to solve one massive, massive technical hurdle.
And that hurdle has a name: double spending. It's pretty easy to get your head around. With a physical dollar bill, once you give it to someone, it's gone. You don't have it anymore. But with digital stuff, right, you can just copy and paste it forever. So how in the world do you stop someone from spending the same digital dollar over and over and over again? Yeah, this slide shows the problem perfectly. If this little digital pig is your one digital dollar, what's stopping you from just copying it and sending it to 3 different people? Normally, a bank is the one who stops this. But if you don't have a bank, you need a completely new kind of solution. And this is where we get to the big twist. The solution to that double spending problem wasn't just about creating Bitcoin. No, the real revolution was the technology running underneath it, a completely new way of keeping records.
Okay, so this is a super crucial point. Bitcoin and blockchain are not the same thing. Bitcoin is a currency. Blockchain is the technology that lets that currency exist without a central bank. Think of it as the shared public ledger for every single transaction ever made.
At its very heart, a blockchain is really just a ledger, a book of accounts. But unlike a private ledger that a bank keeps locked up in a vault, this one is completely different in how it's built and how it's maintained.
And this image just illustrates the difference perfectly. The old way, on the left, that's client-server. All the data flows through one central authority. The new way, on the right, is a peer-to-peer network. Every single person in the network is connected to each other, and they all work together to maintain the ledger. There's no single point of failure or control.
So this is what we call a distributed ledger. And you can think of it this way. Instead of one person or one company holding the official truth, everyone holds an identical copy of it. When a new transaction happens, it gets broadcast to the whole network, and basically everyone has to agree on it. That is how you get trust without needing a middleman.
Okay, so everyone has a copy. That makes sense. But how do you stop people from cheating? How does this whole network stay secure and in sync? Well, that's where the chain part comes in. This is literally where the chain in blockchain comes from. Transactions are all grouped together into these blocks. And each new block contains a unique cryptographic fingerprint, it's called a hash, of the block that came right before it. This creates this permanent, unbreakable link, forming a chain of blocks that goes all the way back to the very first one.
And inside each block, things are super organized. All the individual transactions are bundled up and then summarized into a single unique digital fingerprint. Then, that fingerprint gets combined with the fingerprint of the previous block, which is what creates that super secure link in the chain.
But wait, who gets to add the next block to the chain? This is decided by a process called proof of work.
All over the world, you've got these powerful computers, they're called miners, and they're all competing in this massive race to solve a really, really difficult math problem. The first one to solve it gets the prize. They get to add the next block. And it's this constant, energy-guzzling competition that makes the network so incredibly secure.
This slide explains perfectly why cheating is just so hard. Let's say the whole network is working on adding block 91. Now, if some hacker wanted to change a transaction way back in, say, block 74, they can't just change that one block. Because every block is linked, they would have to redo all of that difficult proof of work for block 74 and 75 and 76 all the way up to block 90. And, get this, they'd have to do all of that super expensive computing faster than the entire honest network can create just one new block, block 91. It is, for all practical purposes, computationally impossible. So what we have here is this incredibly secure, decentralized system for keeping records. And yeah, it started with money, but the potential is just so much bigger. What else can we build on a foundation of pure digital trust?
It's also really important to know that this technology can be adapted, right? While Bitcoin is totally public and open to anyone, big companies can also create private blockchains just for their own internal needs, or groups of companies can form a consortium chain.
Now, this is where it gets really, really powerful. You can actually build programs that run on the blockchain. They're called smart contracts. And the best way to think of them is like a digital vending machine. If you put in $1, that's the condition, then you get a soda, that's the outcome. It happens automatically. There's no cashier needed. And when you combine this secure ledger with these smart contracts, the possibilities are, well, they're practically endless. I mean, think about it. Transparent supply chains, where you can track a head of lettuce from the farm right to your table. Secure and auditable voting systems, managing property records, insurance claims, your medical data, even making charities more transparent so you know exactly where your donation goes. Basically, anything that currently relies on a trusted middleman could potentially be transformed by this.
So we've kind of come full circle. Blockchain isn't really just about digital money. It's about creating a whole new foundation for how we interact in the digital world, one that's based on cryptographic proof instead of just having to trust some third party. People call it a trust machine. And that leaves us with a really fascinating question to think about. What part of our world should we rebuild with it next?